partner about whether you'd like to come up here. There we go, wild animals and eyeballs. Hands up. 1, 2, 3, 4, 5, 6. 2.
Right. I'm just gonna, I'll write it all out, why not?
You minus x from each side.
That's how I, but maybe I'm not, I have no clue.
Okay,
Then you divide both sides by -1. And you get the square root of 4x plus 12 equals x. Then you
Squared it.
square both of them,
Yeah.
which gives you 4x plus 12 equals x squared. Then you minus x squared on both sides.
and you just got, what was it? -2 and 6.
And then you solve for either -2 or 6.
So how did you know that 6 works and -2 doesn't?
Plugged -2 back in and it was like -4 equals 0 or something.
Okay. So when you plugged in -2, it didn't work, but 6 did. So cross off -2. You don't have to show your work. Just circle the 6. Good job, ladies. Any questions? Any issues? Yes.
Is it always gonna be a positive one?
No. Sometimes they both work.
Then you just write both of them?
Yeah. Usually at least one of them will be an answer though, so, but don't skip steps, but generally if one of them's wrong, the other one's gonna be right. But it doesn't always happen that way. Okay, example 6. Keep an animal. How many you got now?
I don't know, like a small drawer full.
Nice.
All I know.
All right, next one, and this is gonna be the easiest one we do. All right, so x to the 3/5 equals 27. Ideas? Don't make me call on Kyle again. Emma? Right, okay, so if it was a square, we do a square root, but it's a 3 on top, right? So we do a cubed root. I agree with you, but we can actually take care of both of them at the same time. Kyle.
But you just gotta divide by, or multiply each side. Divide each side by 3/5.
No.
That is, no.
You can actually do a balance thing, though. Mason?
If you do, like 27 is like, does that have something to do with 27 being like 3 and a third?
Yes?
I'm not sure where to go with that, but
Okay.
that looks like what.
So like kind of what Emma was saying, where like a third power, right, is the same as a cubed root, right, to undo it. So, but you can actually do it all at once. You can do a 5/3 power on both sides. Well, you said multiply.
Isn't that multiplying?
No, this is a power.
Oh, I should say multiplying the power.
Yeah, so it is, but and why? Why is it? Because here, what does it end up to be up here? 1, which is what I'm trying to do. I'm trying to get x to the first power. But you can also think about it. Do you remember when it was like, this is the same thing as 27 to the 1/3, like that, right?
No.
So you could basically you could do it like this. if you wanted to do this in your head. So what's the cubed root of 27? 3, and then if you take 3 to the 5th power, you'd have your answer. You can actually do it all at once though, so everybody try it in your calculator right now. You probably don't have calculators, do you?
32.
Stevens, that's when I wasn't lying. I did it earlier.
I believe you, you just didn't say it right, huh?
Yeah.
Okay, who's 9? Anybody? How about, does everybody have a calculator right now? Well, sweet. Okay, so you could actually do it all at once. You can put in your calculator 27 to the caret and then make sure that 5/3 is in parentheses. It's the same thing as 3 to the 5th power, which is what, is it 243?
Yeah.
That also works. Like for example, if I had, what is x to the 4th power equals 16. What's x?
2.
2 to the 4th power is 16. You guys just know that automatically, right? But if you put into your calculator a 4th root, which is the same, or 1/4 power, which is the same thing as a 4th root, that's how that works. What were you going to ask, Mason, or were you just awkwardly like,
No, so I got, I'm writing what you just did. So I did the,
27 caret?
yeah, for example, 6, I just looked at what you were doing before we entered into the calculator, and then I got like 3 to the 5th power.
Right, which is 243.
Yeah, so is 243 simpler?
Yeah, they're both the same. So you could just do 27 to the caret parentheses 5/3, or because you were automatically thinking, look, the 3rd root of 27 is 3.
Yeah.
Now if I just take 3 to the 5th power, I've got it.
Yeah.
That works.
Okay.
Do it every time like that. I'm glad you can think that way. Not all of us can. Okay, so let's do one more. This one's worth a prize. Okay, now here's the question. Can you guys all see that what we would do to balance it is we would have to have a 3/2 power? Or in that case, you could think square root is 16 and then to the 3rd power. And we also have to add 4, right, to get that x by itself, but what comes first? The power. Do you see how like the power is like the stuff on the outside? We're going to remove that first before we touch the inside. Okay, try it with your partner right now. See if you can get the right answer.
So,
No, you can't do that.
Why not?
Because like if it was a square, that would mean that times itself twice, so it'd be x minus 4 times x minus 4, and 2/3 would be 2/3 times we want to do that, which is impossible to do in the first place. So we've got to take care of this first. So first get rid of this, and then get rid of that by doing something like we just did to both sides. Mm-hmm. It's all the minutia, these little weird algebraic problems. Minutia means all of the little tiny details that most people don't think about. It's not just math, it's anything. Literally, and then the next chapter, or the next section is inequalities and absolute value inequalities, which we really already know how to do. I'm just going to remind you. And then that's it for the algebra. And then next chapter, we're gonna tackle some, graphing, where I'm gonna give you those packets where you have like equations for every single kind of graph you would need. And then we'll hit some, logarithm stuff, in chapter 4, and then we're gonna jump to trig. So this is as tough as the algebra gets. The trig is gonna be